Hello, in this video, we will discuss about the structure, classification and nomenclature of alcohol. And here, alcohol are the compounds containing the functional group OH is the functional group. OH is the functional group of alcohol. And it is represented by general formula ROH. Now, as you know from the Lewis structure, the oxygen is bonded with two bond and it will possess two lone pair of electrons. So in general, the structure of alcohol involves the oxygen atom bonded with one R group and the hydrogen and with two lone pair of electron. And when we consider these two lone pair of electrons there, then the oxygen has four things attached to it: two single bond and two lone pair of electron. With that, the oxygen here is sp3 hybridized. Okay, it is sp3 hybridized. So since it is sp3 hybridized, the bond angle or ROH bond angle, this is supposed to be 109.5 theoretically, 109.5 degree. But however, since these two lone pair of electron occupy somewhat larger space, these two bonds are a little bit squeezed. So this bond angle is usually less than actual bond angle. ROH bond angle is less than 109.5 degree. So specifically, if we consider methanol, in methanol, this angle is somewhere around like 108 point. This angle is 108.9 degree. That is the angle in methyl alcohol or in methanol. So the take-home message here is the lone pair of lone pair of electron in oxygen of alcohol molecule is sp3 hybridized, and the bond angle ROH bond angle is less than 109.5 degree. It can be like 108, 107 depending upon what is the R group involved in this molecule. So that is the structure of alcohol. Okay. Now next item we wanted to talk about here is the classification of alcohol. Okay. Based on the type of carbon in which the OH group is attached, the alcohol are classified into three types of alcohol. Three types of alcohol. And if the OH group is attached to the carbon which is connected with one other carbon group or one R group, and it is attached to two other hydrogen atom, this type of carbon is called primary carbon, and the alcohol we call that as primary alcohol or 1-degree alcohol. If the carbon is attached to uh, two hydrogen and one R group, that will be your primary alcohol or 1-degree alcohol. If the carbon in which the OH group is attached is connected with two other carbon containing group, this can be same or different, and only one hydrogen, then we call that as 2nd-degree alcohol or 2-degree alcohol. And if the carbon that possesses the OH group is connected with no other hydrogen, all three are the carbon containing group, it can be R or R prime, then we call this as 3-degree alcohol, 3-degree alcohol or tertiary alcohol. So these are the three types of alcohol, and whenever you see certain type of structure or the alcohol structure, you should able to identify what type of alcohol is that. Say for example, suppose you are given the structure like this here, and you are asked, so this OH group here is what type of alcohol, and this OH group here is what type of alcohol. So how do you identify that? Just look at for example, if we wanted to know what type of alcohol this this OS group is, then you can see this is the carbon in which the OS group is attached. It is connected with only one carbon containing group, and there are two hydrogen. If you want, you can write that this carbon has two hydrogen. That means this alcohol is 1 degree or primary alcohol. Similarly, if we wanted to know what type of alcohol is this second OS, this OS group here, then you can see that this is the carbon that poses the OS group. This carbon is connected with one carbon here, one carbon here, two carbon group. That means it has only one hydrogen. That makes this alcohol as second degree alcohol or 2 degree alcohol. This is how we can identify the type of alcohol based on this knowledge. And it is very, very important for you to identify the type of alcohol as you see the structure of the alcohol. Now, the next very important point that we wanted to discuss in this topic here is about the nomenclature of alcohol. Nomenclature means how we name the alcohol. Okay, and when we discuss about the nomenclature, we focus on IUPAC naming of the alcohol. In IUPAC system, alcohol are named by using alkane, and we use OL as the suffix. And when we join these two terms, then we drop out this E. So the alcohol are named as alkane plus OL. That will be alkanol. Alkanes are named as alkanol. So OL. Be careful with this one. OL is the suffix. That is what we use. Okay. And the second point that we wanted to mention here is then OS functional group, the carbon containing OS functional group, we try to give the least number. When we numbering the chain, the least number for carbon containing the OS group, containing OS group. These 2 points that we need to consider very well. Okay. Now, let us see, for example, we wanted to name this alcohol here. This is the alcohol. Now, here, first of all, we find out the longest carbon chain, 1, 2, 3, 4, 5 carbon chain. Therefore, this will be pentane. And since there is a OS group, this will be pentane plus OL. So it will be, obviously, it will be pentanol. Pentanol. But we drop out this E, so it becomes pentanol. Now we need to specify what is the position of this OS group. So we wanted to number the chain. So as we discussed here, we try to give the least number for the carbon with the OS group. So we number from, in this particular case, we number from right to the left. So 1, 2, 3, 4, 5. So this becomes 2 pentanol. So that is the way that we name this alcohol. Now, with this, if there is any substituents in the alcohol, then we give the priority for the OS group, and then we name accordingly. For example, if we have the alcohol, say for example, here is the OS group, and we have, suppose here is the CS3 or methyl group. Now, if we wanted to name this alcohol, then again, here we find out the longest carbon chain, 1, 2, 3, 4, 5, 6 carbon chain. So that will be hexane. And since there is a OS group, so it is hexane plus OL. We drop out this E, so it will be hexanol. Hexanol. But we need to specify the position of the OS group. So that is why we need to number the chain. Again, we try to give the least number for the for the carbon with the OS group. So 1, 2, 3, 4, 5, 6. So it is 2 hexanol. Once we give the position 2, now we substituents here, it is in position number 4. So that will be 4 has the methyl substituent. 4-methyl 2-hexanol will be the name of this alcohol. Okay, and by the way, in our previous naming system, we have mentioned that or we try to give the least number for the carbon with the substituents. But however, please remember that whenever we have the alcohol functional group, we give the priority to the alcohol functional group, and we give the least number for the carbon with the functional group. So that is the way. So this carbon will get 4 with the methyl group, so it is 4-methyl 2-hexanol. Okay, so that is how we name this uh, alcohol. Sometimes, however, that is another very important point, if we have multifunctional group or more than one functional group, right? Say for example, we have, suppose you have here C double bond OOH, and here is say OH group. Here you have alcohol functional group, and we have here carboxylic acid functional group. Now in this case there are two functional group, so the question comes here, which one we should give the priority to, right? So that is when there is a sequence for the priority for the functional group, and I strongly encourage you to memorize this sequence. So we always, if there is a carboxylic acid functional group, we always give the highest priority to that, so that will be acid will get the highest priority, and second priority will be for ester group, and third priority will be for the aldehyde, and then next one we go for the ketone, and next then only it comes number 5 will be the alcohol, and then we'll have the amines, and of course after that there will be the alkene, and so on and so forth. Number 8, that will be alkyne. This is the priority, so it will decrease in this order. Now since in this case, see here, there is a alcohol functional group, there is acid functional group, so based on the priority, acid has the highest priority. So in this case we take alcohol as the substituent, this will be the substituent, and we prioritize the carboxylic acid, and acid are named by adding the suffix oic acid, oic acid. And since the alcohol will be the substituent here, we call that as the hydroxy group. Alcohol we named as the hydroxy group, hydroxy. Okay, this is not OL anymore, this will be the hydroxy functional group because that is less priority. So the name for this one will be, so this oic acid or the carboxylic acid will have the highest priority, and that will be carbon number 1, 3, 4, 5 carbon. So this will be pentanoic acid, pentane plus oic acid, so pentanoic acid, because there is a 5 carbon group, 5 carbon chain, that is pentanoic acid. And carbon number 4 has the OH group, so this is 4 carbon has the hydroxy group, 4 hydroxy pentanoic acid is the name of this compound. So that is how we give the hydroxy as the substituent. We consider hydroxy as the substituent when it is the higher priority group. Let us see one more example here for with this category here. Say for example, we have here somewhere there is like a, say there is a aldehyde functional group, and also there is the say OH group also. Now again, as you can see in this list, aldehyde has the higher priority than that of alcohol, so we have higher priority for the alcohol aldehyde, and aldehyde are named by adding the suffix al. We will discuss that later in the chapter when we discuss about aldehyde also, but al will be the suffix for aldehyde. So, and here since this aldehyde has higher priority, uh, the OS group we consider again as what? It is the hydroxy group. When the OS has the higher priority, we call that as OL suffix. But if you have other functional group that has the higher priority, then we have to put OH group as the substituents, and we consider that as the hydroxy. That is the point that you need to note